What is a digital twin and what are its benefits? Let me show you using a demo of the work we are doing with SAP for their new product, SAP Predictive Engineering Insights enabled by Ansys. This digital twin is part of the equipment on an offshore oil platform, an electric submersible pump, or ESP. It is an important part of the equipment on the seabed used to pump the oil from below the surface of the earth. The ESP contains many individual pieces of equipment, including electric motors. Let's take a look at the digital twin of the ESP. Here's the twin created with Ansys Twin Builder. We can see that the head, flow rate, current, and winding are all within normal range. Sand is introduced into the flow of the pump, resulting in a detrimental effect on the operation of the pump motor and the pump itself. As the amount of sand in the flow increases, the operator attempts to correct this to maintain flow, but the motor current and winding are jumping up into the red areas on our dials. The performance of the pump degrades, remaining lifetime of the pump decreases, and warning indicators appear. The pump operator needs to take corrective action in order to prevent further damage to this expensive piece of equipment. We disconnect from the physical asset to perform manual testing on the twin to investigate the best-case scenario for restoring normal pump operation. First, we increase the RPM on the twin of the motor. This is not correcting the motor overload, though, and the remaining lifetime of the motor continues to decrease. Next, we decrease the RPMs of the motor, hoping that this will resolve the overload situation. It does, but this has resulted in a low head warning. To correct this, we lower the amount of sand that can enter the pump, but the problem persists. In order to diagnose the root cause of the problem, we need to take a look at the 3D simulation of the pump itself to see what is occurring. Here is the actual 3D simulation of the pump created with Ansys solutions. We can zoom in and take a look at what is happening to the pump. We need to confirm that the amount of sand concentration is the cause of the pump erosion based on the operating conditions of the pump. We can see the sand in yellow and the brown areas of the pump that are prone to erosion. The eroded tips of the blades appear as the red areas. Based on the different scenarios that we have run on the twin, it appears as though the pump must be replaced. Let's make sure that this is the case by verifying through simulation on a twin of a new pump. If we put a new pump in, does the problem go away? It does. But replacing the pump immediately isn't feasible due to its remote location, so the operator must optimize the current pump through simulation in order to increase its lifetime so that it can run until the next maintenance window for the existing pump. Why is all of this important to know? If operators are able to predict when the pump may fail, maintenance and replacement schedules can be adjusted accordingly, saving time, effort, and money.